Question 3, paper 2. Probability that a certain rugby player scores from each place kick he attempts is 85%. During a particular match, he takes 5 place kicks. Find correct 4 decimal places. The following. Okay. What I noticed there is that the probability of him kicking remains the same. So the probability of him not getting the kick is 15%. I might just write that here. What else? Okay, they want me to give my answer to 4 decimal places. Right, so probability, not my strongest area in maths. So I'm going to go through my little strategy. One is that I need to lengthen out the sentence and check if it's a junior cert question. If it's not that, then I'm going to check if it's Bernoulli, because Bernoulli is the most common question at Leaving Cert probability. If that doesn't work, I'm going to just look for, maybe just check if they mention maybe conditional probability, maybe the word given. If that doesn't work, I'll check if they mentioned independent events. I'll fill that formula in. If that doesn't work, I'll check if they asked about a fair game or expected value. And if that doesn't work, might have to just do out a sample space or something like that and see if I can list it all out. So, or maybe mutually exclusive events. Anyway, that's my strategy. That's where I go. So I'm starting off, I'm lengthening out the sentence. He takes 5 penalty kicks and he scores exactly 3 of the 5. So that means that, and I'm just going to write a little list for myself here. If he could score maybe the first 3 and then miss and miss. Or he could score, miss, score, miss, score. Or he could score, miss, miss, score, score. Or, now, it's possible for me to do this. It's possible for me to completely lengthen out the sentence and it would turn into a sample space here. But I'm not, I don't really want to do a full sample space for something like this. So I'm going to move on to my next thing. Check if it's a Bernoulli. I have my checklist. And this is the issue with my way of doing probability, is that I have to have an awful lot of stuff in my head for probability. So Bernoulli, does it meet the checklist for Bernoulli? So is there a finite number of events? Yeah, 5. Does the probability remain the same throughout? Yes, I actually noticed that at the start. Is there just 2 outcomes, success and failure? Yes. And is there is there kind of what is the word? It's not, it doesn't have to be particularly that he scores and then scores and then scores. There's a variety of options here. So it's not that he has to score in a certain, he has to score the last 3 maybe or whatever. No, so we have choice, I guess we're choosing here. So that ticks all 4 of Bernoulli's checklist for me. I'm going to use a Bernoulli. So 5 altogether. He scores 3 of the 5. So that's 5, choose 3. The probability of success, 0.85 to the power of how many successes I want, and failure to how many failures I want. Throw that into the calculator and round it off to 4 decimal places. He scores for the 3rd time on his 5th attempt. Is there choice? No. Okay, I'm going to go back to the start of my checklist then. So I need to lengthen this out. So he scores for the 3rd time on the 5th attempt. So we've 1, 2, 3, 4, 5 attempts, and he definitely scores here. And what are the chances of him scoring? 0.85. Okay, so that's me lengthening out the question. Now, what happens on the first 4 then? If he scores for the 3rd time here. Okay, so then he has to score twice here. I wonder, is this little part here a Bernoulli? So this is like an obscure kind of Bernoulli question. Because I really had to lengthen that out and figure it out. So, is there a finite number of events? Yes, 4. Is there success and failure? Yes. Is there choice? Yes, there is. He can score any 2 of those 4. And does the probability remain the same throughout? It does. So this part here is a Bernoulli. That's 4, choose 2. Probability of success to how many successes I want, and the probability of failure to how many failures I want. That's the first 4, and we want him to score on the 5th one. Throw that into the calculator. And do we have to go to 2 decimal places? Yes, so we're doing 4 decimal places, everything here to 4 decimal places. So 0.0829 when I throw that into the calculator. And he scores on at least 3 attempts during the match. So I'm going back here again to the start of my own checklist here. So I'm going to lengthen that out. So he scores at least 3 attempts during the match. That means that we can either do that he scores 3, or he scores 4, or he scores 5. So he scores 3 out of 5. I've actually that done. Or means add. He scores 4 out of 5. No, I don't have that done. So I need to do that. So that's 5, choose 4. Probability of success to how many successes I want, and the probability of failure to how many failures I want. Throw that into the calculator, and we're at 0.391504. And or he scores all 5 out of 5. So that's 5, choose 5. 0.85 power 5. And 0.15 to the power of 0. And that's 0.44. 3705. Add them all together, round off to 4 decimal places, and you're at 0.9734. Then separate question. A, B, and C are 3 events. A and B are independent. Probability of A is a third. A intersection B is a 12th. Probability of C is a half. Probability of B union C is 5/8. So we need to find B intersection C. A, B, C. I'm just going to try and give myself as good a diagram as I can here first. Probability of A happening is a third. A intersection B is 1/12. Probability of C is a half. And B uniting with C is 5/8. Okay, so firstly, I'm just going to go with the fact that they said they're independent. And like, to me, this is lengthening it out, but I actually can't really fill in anything. So I've lengthened it out. Bernoulli, no. No, not a Bernoulli. Have they used conditional probability? No. Have they said independent events? Yeah. So I'm going to write down my independent events formula. Probability of... Now, A and B are independent. So probability of A times probability of B is equal to the probability of A intersection B. That's my formula for independent events. The probability of A, a third. Probability of B, I don't know, I'm going to call that X, is equal to the probability of A intersection B, that's a 12th. Bring this over, becomes division, and we end up with x being a quarter. So that's the probability of b happening. So their probability of b now, I have a little bit more information, is a quarter. Find B intersection C. And they talk about mutually exclusive. What's my formula for mutually exclusive? So probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Okay, so have I got A union B? I'm only doing this because they mentioned mutually exclusive, but I'm doing it with A and B just in case. Mostly because I don't really know what else to do in order to work out some of this stuff, so I'm just going to mess around. A union B, do I have that? I don't. Probability of A, I have. The probability of B, I have. And minus the probability of A intersection B. Wait, I have all that, so I can find this out. I'm not sure it's going to be helpful, but I can find the probability of A uniting with B, which is a third, plus the probability of B, which is a quarter, minus the probability of A intersection B, which is a 12th. Third plus a quarter minus a 12th is a half. So just in case, probability A union B is equal to a half. That might be absolutely useful or useless to me, but I'm just doing it there. How about find B intersection C? So maybe we'll do this with the probability. Maybe we'll do it with B and C. So B union C. So this is my mutually exclusive stuff that's going on here because they mentioned it in the question. B union C is equal to probability of B plus probability of C minus the probability of B intersection C. Okay, so you can see I need to know my formula as well here. B union C, have it, 5/8. Probability of B, I just worked it out, a quarter. Probability of C, given in the question, a half, minus, let's call this Y this time. So this is what I'm looking for, that's B intersection C. Is what I'm about to find out here when I find out what Y is. Bring everything to the left, so that's 5/8 minus quarter minus a half. 5/8 minus 0.5 minus 0.5 gives me minus 1/8 is equal to minus Y, so Y is equal to 1/8. So the probability of B intersection C is 1/8. That's what I've just been asked. And state whether the events are mutually exclusive or not. So in order to show that they are mutually exclusive, there would be no crossover between B and C. Now, what is B? Probability of B happening is a quarter. And the probability of C happening is a half. So B and C happening, that's a quarter and a half. It's a quarter and a half. Gives me 1/8. So when I work this out, I get 1/8. Which means that there's an 1/8 in here. So they're not mutually exclusive. There is a crossover. Okay. So using this, I'm after working out what B intersection C is. It's an 1/8. And think about it. If you work out that B intersection C is an 1/8, well then there's a crossover. Therefore, they couldn't be mutually exclusive.